All right, guys. Adding and subtracting rational expressions. So you're just adding and subtracting fractions. To add and subtract fractions, you must have a common denominator. Good. And in our case, we're going to get the least common. Well, yeah, less simplifying, yeah. Gracious. Least common denominator, we'll abbreviate that to LCD. All right, so we'll start with example. I'll go back to doing numbers because letters bothers you guys. We'll start with an easy one. We are. I put X's in the very first problem instead of doing the elementary school problem. Because y'all are smart. Okay. So, I did not mean that sarcastic.
I think
Yeah.
me too.
10 over 4. All right, we believe it. So, is the denominator the same? Yeah, so we don't have to do any work to get it there. So, least common denominator is 4x. And what's the rule when we're adding after the denominator is the same? You just do what? Keep the denominator and add the top, right? 7 plus 3 is 10. And then we always, at the end, try to do what? Reduce, simplify the fraction. So 2 goes into 10 and 2 goes into 4. 5 over 2x is the final answer there. Well, I was just about to mention that. How would you find the excluded values? All right, set the common denominator equal to 0 and solve it. That's how you would find those. Okay? We're going to pass on those today. We'll have to do that plenty tomorrow, so I'm going to pass on that today. You know how, though, right? Okay, as long as you know how. Because tomorrow we're going to have to do that, so.
You ever like school? I don't know how.
35 years of school. It's awesome. All right, so denominator already the same? Yeah, it's perfectly the same. It's x plus 3 and x plus 3, so that's the same. So we do what with the numerators? Subtract them this time. So 10 minus 17 is -7, and x plus 3. Does that simplify in any way, shape, or form? No. So if it would just stay this easy. Man, gosh. All right, 2x plus 2 over x plus 2 plus 2 over x plus 2. Denominator already the same? Yeah, so we can just go ahead and add like terms in the top. Be 2x plus over x plus 2, but we got to see if we can simplify. That top part has a GCF of a 2. So the x plus 2 is just 2. Yeah. It goes back to being able to do what we did yesterday, simplifying a fraction. You need one of those pens like we had back in the 90s that had like 4 different colors in it.
Oh my! I was trying to do all yeah. You ever had that one where like goes in circles?
No. Is that it had like a motor in the top of it? That's funny.
Yeah, and then like the bottom like that.
My rich friends had those. I didn't have one. I'm just kidding. I know what you're talking about. Yeah. Always made me dizzy. I couldn't do that. They had one. Yeah, I don't remember those. Yeah, the top part would be 4x minus 12 over x minus 3, so because the denominator's already the same, right? So far we're in good shape. All right, so 4 is the GCF. You get x minus 3. And x minus 3. And so the final answer is 4. Yeah, it is satisfying to cancel those things out. I gave you a hot 40 of them yesterday. No, without the smart people stuff, just the easy stuff. Everything's already factored for him. Could you like do that for the quiz? I'm sure y'all wouldn't mind that at all, would you? All right. Denominators already the same. Good job. Nope. What do you mean? Yeah, it's a what? Difference of squares. This is 4x minus 5 and 4x plus 5 on the top, and then 4x plus 5. Yeah, so the final answer is 4x minus 5. And we're about to. All right, so pretty easy when the denominator is already the same, right? That's too easy, right? Not even algebra 2 level. It's barely algebra 1. All right, so let's get. All right, let's get one that's a little tougher. 3 over 7 plus 5 over x. You're not. It's not an equation.
Now is when you quit and leave school.
Okay. All right. Maybe this is where we need to go do an elementary school problem. So let's do an elementary school problem. It's 3 over 7 plus 5 over, let's do 9. Okay, so to get a common denominator, you got to look and say, okay, are there any common factors? And then what's the smallest number that both of those go into? So what's the smallest number that 7 and 9 both go into? 63. 63 happens to also be what? 7 times 9. It's the same. That's that product, right? So the way of finding the common denominator for this one is the same as finding the common denominator for this one. So there you go. So it isn't that hard, right? You multiply the denominators together because there's no common factors. 7 and 9 don't have any common factors, right? 7 and x don't have any common factors. So finding the common denominator is just multiply it together, right? So your least common denominator for this problem is going to be 7x. So then you got to go in and fix each fraction to have that denominator. So how do you make 7 into 7x? Multiply it by x. So if I multiply the bottom part by x, I have to do what? Multiply the top by x. How do I turn this one into a 7x? Multiply by 7. If I multiply the bottom by 7, I got to multiply the top by 7. So I get 3x over 7x plus 35 over 7x, bless you. And then now the denominators are the same. 3x plus 35 over 7x. Will 3x minus 35 factor? No. So there's nothing I can do. Okay. We'll get there.
Friday.
Not yet. No, today you will. All right, so let's say we had 8 over x parentheses x plus 2 plus 9 over x. It's a little more complex. Okay. So here's the difference in this one compared to example 6. You look at your denominator. look at the left one. It's in what form?
Like that.
It's already factored, right? Does it have a common factor with the other denominator?
Yes, sir.
Yeah, it's both of them have the x. So the least common denominator is going to have the shared factor x, and then anything the other denominator doesn't have, the other factor. So this one has two factors. It's got x and x plus 2. So this one needs an x plus 2 to make it the same, right? So the least common denominator is going to be x times x plus 2. Well, plus sign look weird. Fix it. So second fraction needs fixing. We got to multiply it by x plus 2 on the bottom. But if I do that on the bottom, got to do that to the top too. And then got 8 over x plus 2 plus what's on top of the other fraction? Yeah, 9x plus 18. So the numerator you're going to have to multiply out. The denominator don't. Okay, you don't multiply out the denominator. You don't have to do that. Okay, so combine like terms will be 9x plus 26 over x plus 2. Check to see if it'll factor. No, it won't, so that means I'm done.
Please don't have that yet.
Yeah. See. Yeah, we just got out of the elementary school level. Oh yeah, this is past middle school. Y'all were advanced, so I moved you up a couple of grades. It is.
All the odd years are hard years.
No.
I'm glad senior years and even.
Like freshman year was easy. Yeah, freshman year was easy. Well, like getting to.
But that's the first year of high school.
We're easy, and we didn't want you to leave. All right, so look at the denominators on this one. What do you notice about the first one?
It's got an X factor.
It's got x squared minus 3x, right? Which could be factored using GCF. So the factor would be x parentheses x plus 3.
So you just need to multiply the X to the other one.
So the least common denominator would be what? Yeah. The longer one. Yeah, absolutely. Well, it's not necessarily always the longer one. It depends on what the other one has. All right, so it needs to have x and x plus 3 because this one already has all those things. And then this one, so this one needs a what? X. We'll multiply top and bottom by x. 7x over x plus 3 minus 3x over x plus 3. And then that'd be 4x for x plus 3. And does that simplify a little bit?
Yeah, the X.
Yeah, those x's will cancel. Yes, that's good for Tucker. Should feel good about that. All right, so anytime you've got exponents on the denominator and pluses and minuses, you've got to think, hey, that's probably going to factor a little bit because we're doing rational expressions. The whole idea is to learn to do that kind of stuff. So you've got to factor the denominators always. So here we had to factor that first one. We found it had a common piece with the other side. So we had to, get them the same out of that. Let's get to one that's a little bit more advanced. It'll help you. I kind of try to start that habit now because tomorrow we're going to use that LCD to get our excluded values with it. So if you'll start that habit now, it'll help you tomorrow. Okay, so if I factor the denominator over here, it's 3x and x plus 1. So is there anything in common between this denominator and this denominator?
Yeah,
3 and x are both in common there. So 9x squared is really what?
3 times
3 times 3 and x times x, right? So, or 3x times 3x. That's that's kind of the thinking that we're using there. So how many 3x's are in common? One of them. But this fraction has how many of them? 2. So to be a common denominator, there's going to have to be 2 of them, right? So I'm going to have 3x, the other 3x, and then the x plus 1. No. Because it really, this is 9x squared, x plus 1. Is what that really is. And that's how I'm going to write it. Because here's the 9x squared is made up of 3x times 3x. And then we're sharing one of them. And then both of them need an x plus 1. So this first fraction, what do we need to add to the denominator or multiply? The x plus 1. And then what do I need to put on the denominator for the second fraction? Another 3x. That's going to give me 7x plus 7. X squared, x plus 1. Then plus 3x squared. Combine like terms if there are any. If not, put it in descending order. I need to try to simplify that if at all possible. So anything multiplied to be 21 and add to be 7. No, so it won't factor. That means it's done. Always going to try to simplify. Sometimes they don't. Sometimes they do.
Good morning. Thank you very much.
All right, so let's get to a little bigger one. X plus 3 over x plus 4 parentheses x minus 1 minus 2x minus 5 over x plus 2 x plus 4. So the denominators are already in factored form, so I'm kind of stepping into this. What do they share? An x plus 4. So the least common denominator we know for sure is going to have an x plus 4 in it because that's the shared piece. Then what are the factors that are not shared? Yeah, x plus 2 and x minus 1. So it needs all 3 of those. Okay, only one of the one that's shared, and then one of each of the others out of that. So the first fraction, what part does it need? The x plus 2, right? So I'm going to multiply top and bottom by x plus 2. The second fraction, what does it need? X minus 1. So multiply top and bottom by x minus 1. So the top part, we're going to multiply that out. X plus 2 times x plus 3. So it'll be x times x is x squared. 2x and 3x is 5x plus 6 over x plus 2, x plus 4, x minus 1. It doesn't matter what order you write those denominators in. The second fraction, we're multiplying 2x minus 5 times x minus 1. So that's going to be 2x squared minus 2x minus 5x minus 7x plus 5 over, I'm just going to copy the other x plus 4. Once we get the denominators the same and the numerators multiplied out, we can do the operation, subtraction, of the like terms. So x squared minus 2x squared would be negative x squared. 5x minus negative 7x would be Yeah, plus 12x, and 6 minus 5 would be plus 1. And then the denominator, x plus 2, plus 4. That numerator, will it factor? No, nothing multiplying to be -1 and adding to be 12. If the top part would factor, and you get a matching factor, just like we had yesterday, you got to have a matching factor to cancel it out. Or if there's a number out in front, like a GCF or something, you can cancel it. No, because remember, if they're tied together with addition and subtraction, it's got to be matching this whole factor completely. And like, so here with the 1 and this minus, that's x minus 1, not just a 1. So you can't cancel pieces. It has to be a complete factor to be able to cancel that. Yeah, by itself. Oh, yeah, I got plenty more. Number 11. Let's do x plus 1 over x squared plus 4x plus 4 minus 6 over x squared minus 4. So denominators are definitely not the same, so I'm going to try to factor those if I can. So x squared plus 4x plus 4. On the first fraction? Yeah. X plus 2 twice, right? Do the x method on that. The other one is a difference of squares. Yeah. So what's our common denominator then? So we got an x plus 2 that's shared, and then got another x plus 2 and an x minus 2. So the first fraction needs what? Second fraction needs another x plus 2. Multiply that out. So we got x squared minus x minus 2 minus 6x plus 12 on the top over there. And I'm going to rewrite my denominator kind of a shortcut way. Simplify by doing the operation. X squared, there are no other x squared, so I'm going to go over. Negative x minus 6x. Negative 7x. Negative 2 minus 12. Negative 14. Try to factor that. Multiply to be negative 14. Add to be negative 7. Nothing does that. So that is done. Factoring the denominators. That should be your first step. Look to factor the denominators. Second step is look to find anything they have in common. Do they have a common factor? That common factor starts your least common denominator. Then put the other pieces that each denominator has. So the common factor here only shows up once, and then you've got the other pieces. Okay, and then multiply it out, or multiply the things that it needs, and then simplify with the operation that's going on there. It really is that process over and over and over. So all that factoring stuff still part of the game today, doesn't change. All right, let's combine what we did yesterday with what we're doing today.
And I thought it was going to be easy, but
It is easy. So we'll do it in elementary school style first.
This showed up on that, whatever it was.
Benjamin?
No, the
Yeah, the admin thing. Yeah.
I didn't know what to do.
Well, we're gonna know today what to do. So, all right. So, here's the big deal. You got this large fraction bar in the middle there. So you got a fraction up top. You got a numerator. You got a denominator. Look at those separate first. Is there anything to do to the top part? No. Bottom part. Yeah. So we're gonna do that part first. So 3/5 is gonna carry over, and then fraction bar. And so I need to add 1/2 and 3/10 together with a common denominator. So that'd be 5/10 plus 8/10, which is, or plus 3/10, which is 8/10, which reduces to be 4/5. Yeah, so it's 3/5 divided by 4/5, but we know how to do that. We say 3/5 times 5/4, and then we follow our rules for multiplication. Cancel, cancel. Okay. Yeah, this is.
Yeah, I don't like
Start
this.
mixing in them X's.
Yeah. Makes it fun, is what it does. That's the word you're looking for, fun.
I understand.
All right, so idea is look at the numerator, look at the denominator, do anything to simplify that and get it into one fraction, and then do the division problem. Okay, so let's look at one that's more algebra 2 level.
Wait, hold up. What are you doing?
Sorry, I needed to change the thickness of a marker to get that large fraction bar, so I was waiting to do that last.
I'm so confused.
Just putting them randomly on the page in different places to see what you do. Yeah. All right, so we look at the numerator. Is there anything to do with that one?
Can we cancel out the numerator and the dot? Wait, no. Yeah.
No.
So we can't.
Yes. Because here's the idea. This is what you're thinking about order of operations wise. When you've got a fraction on top and then an expression on the bottom, it's kind of like there's parentheses around the top, there's parentheses around the bottom. So order of operations says you got to do the top part, anything you can do to that, and then you got to do the bottom part, anything you can do to that, and then work the division problem, because that's how order of operations works. Okay, so we need to work that addition problem in the denominator. But you can't just put a +4.
Multiply an x to one side and multiply x with 4.
There you go. So the LCD for the denominator would be x times x plus 4. And then this one you're going to multiply by x, top and bottom. So we got 5/x plus 4. Since it confused you guys. Over x/x plus 4, x plus 4, plus 2x plus 8 over x plus 4. Okay. So we're not doing anything with the numerator. I've just copied it over. I haven't done anything with it yet. So I just multiplied 1 times x. That's how I got x on top. 2 times x is 2x. 2 times 4 is 8.
So now you cancel out the x plus 4, right?
No, there should be a +4 right there. I said it didn't right. Is that what it was? Now, can't cancel out the x plus 4, so we do the division problem. So we got the 5/x plus 4 over 3x plus 8 over x x plus 4.
Now.
Now you can make that division problem turn into multiplication. So always flip the bottom one. And 5x over 3x plus 8. Everybody loves this stuff. Bless your heart. All right. Let's do another one. Is that right, dog? X or 6 over x minus 5 is the numerator. The denominator, let's make it 3 over x plus 5 minus 2x over x squared minus 25. Okay, so this one factors as x plus 5, x minus 5. That's a good start.
Your least common denominator is x minus 5 and x plus 5.
Okay, so first fraction needs something.
X minus 5. Okay.
All right, so numerator staying the same. Haven't changed it at all. And then the denominator, you're going to have 3x minus 15 over x plus 5, x minus 5, minus 2x over x plus 5, x minus 5. Combine the like terms there, because the denominators are now the same. 6 over x minus 5 over 3x minus 2x would be 1x minus 15 over x plus 5, x minus 5. Yeah, now set it up as multiplication. 6 over x minus 5 times x plus 5, x minus 5. Tucker's favorite part. Six x plus 5. All right. Questions about that part? All of those. Either or. Since nothing's simplified, I'd take it in the factor form or the distributed form. Doesn't matter. Not short problems, but yeah.
There's only 10.
Okay, that's better than
Yeah,
45.
that's like the-
Oh, my first
All right, guys.
14 is a good number.